So the first part of 8.6 was solving exponential. This part of 8.6 is solving logarithmic equations. So there's going to be two different types that you'll run into. There will either be where you see a log on both sides. So that would be where log of something equals log of something. You'll see them on both sides. You need to rewrite each side as a single logarithm, so that means you're going to need to condense. So if you see several logs on the left, you'll need to condense it into one. If you see several logs on the right, you'll need to condense it into one. Then you set the inside equal to each other and solve for x. That could require factoring, could require the quadratic solution, the quadratic equation, or it could just be as simple as just solving for x, like a linear equation. Really easy. So you'll see all different types. If you see, so the other type would be only one side with a logarithm. So that would mean log of something equals like a number or equals something, where you only see it on one side. The first step is you still want to condense the left-hand side into a single log. Then there's two methods. I'm really only going to talk about one of them just because A and B kind of both mean the same thing. But basically, you're going to turn it into an exponential, so you'll switch to be exponential. So that's when you bring the base up and then switch the x and y, like we've done before. And then you solve the resulting equation. So instead of saying 2a and 2b, they both kind of mean the same thing. Switch it to be exponential would be step 2. And step 3 would be solve the equation. So here we have number 1. This would be an example where we have the log on both sides. Go ahead and scratch out the method 2a and 2b. I'm not gonna show you two ways. I'm just gonna show you one. So we want to write it as one single log. I need to condense the left side because I have a 2 in front. And so what do I do with that 2 if it's in the front? How do I condense it? What does that mean? Yeah, it's a power. So it would be the log of x squared equals the log of 9. Once you have them condensed, then you can set the inside equal to each other. So x squared equals 9. So x equals plus or minus 3. But what do we know about negatives inside a log? You can't have a negative inside a log, so just x equals 3. So basically, if I have 3 and negative 3, I only have one solution, and that is the positive 3. Okay, here we have an example where we just have a log on one side. I'm going to cross this out. I need to condense the left side, but another thing that you can do, so if I have a 3 in front, instead of writing like 4 minus x cubed, you can just divide by 3 first on each side. So log base 3 of 4x minus 7 equals 2. And this kind of thing only works when you have just a log on one side. So in the last example, I couldn't have divided each side by 2 because it would have been with another log. So this, I can only divide by 3 if there's a log on one side. It'll make more sense here in a minute. Then, so I've gotten it to where I just have a log on one side equals a number. Then I want to switch it to be exponential. So what happens when I'm switching it to be exponential? The 3 comes up. So 3 squared equals 4x minus 7. So remember, these two switch and the log goes away. So 4x minus 7 equals 9. 4x equals 16. So x equals 4. Number 3, so would this be where I have a log on both sides or a log on one side? Log on one side. So what do I need to do to the left? I need to combine it into one single log. They're separated by a plus sign, so what do I do with the stuff in the middle? Or what do I do with the stuff in the parentheses, I guess? Multiply them. So log base 4 of x plus 3 times 2 minus x equals 1. So I know that you could potentially move the second log over, and so then you'd have a log on both sides, but you still have that random 1 that's in the way. So it still is just a log on one side because you have that 1 and you don't know what to do with it. It's only truly a log on both sides if you have log equals log and there are no other numbers. So then I'm going to FOIL, and I get log base 4 equals, not equals, 2x minus x squared plus 6 minus 3x combines to be, let's see, 6 minus x squared equals 1. Then I want to switch it to be exponential form. So how would I write that? If I'm switching it to be exponential, 4 to the first power equals 6 minus x squared. Then I want to deal with a positive x squared when I'm factoring because I don't like negative x squareds. So I'm going to move, basically I'm going to move everything over here to the left. So x squared plus x, and then 4 minus 6 would be what? Minus 2, good, equals 0. Then how would I factor this? Not 4. Multiplies 2, adds to 1. Negative 1 and positive 2. Gonna have to freshen up on our factoring rules. So x equals 1, x equals negative 2. Would both of these work? So basically how I tell is I look inside these right here. If I plug in 1, I get positive answers because 1 plus 3 is 4, 2 minus 1 is 1. So the positive 1 works. And the negative 1 will sometimes work just depending on when I plug it in if it's still positive inside the parentheses. So when I plug in negative 2 here, do I get a positive answer? Negative 2 plus 3. Is that positive? Yes, so it works here. 2 minus a negative 2. Is that positive? Yes, because it becomes 4. So both of these would work. So you have to check solutions.
Did you have to put them back?
Plug them back into the original.
Oh,
to make sure that they're positive inside the parentheses. So check solutions for positive. Don't just say every negative answer is not going to be true. You have to check it. Okay, try number 4. Would number 4 be log on both sides or log on one side? One side. Okay, so condensing means you multiply. So you get x squared minus 6x to be 1 log. Then change it to exponential. 3 to the third equals x squared minus 6x. 3 to the third is 27. Move the 27 over. Factor x minus 9, x plus 3. Then your solutions are 9 and negative 3. But why does negative 3 not work? Because it's negative. So when you plug it in here or here, they both are negative logs, which are undefined. So only positive 9 works in this case. Okay, number 5, have log on one side. So go ahead and try condensing number 5. So if I'm condensing, the first thing I want to do is bring this power up. So log base 3, x minus 4 squared minus log base 3 of 9. The reason why you can't divide by it on both sides is because not both of the logs have a 2 in front of it. So if you go back to number 2, it had a 3 in front of it, but there was only one log. So then on 5, there's 2 logs and only one of them has a 2. If they both had a 2, then you could. Then to combine it into one log would be x minus 4 squared over 9, because of the minus, equals 4. I know this may look intimidating, but it's not as hard to solve as it may seem, I promise. So writing it in exponential would look like what? What to the what power? 3 to the 4th equals x minus 4 squared over 9. 3 to the 4th is what? 81. Good. How do I get rid of this 9 on the bottom? Multiply each side by 9. Can someone tell me what 81 times 9 is? Nice. What do I need to do to get rid of the squared? Right here. I don't have to. I can just get rid of it. I can just square root each side. So then you get x minus 4 equals, the square root of 729 is 27. Good. And it's also negative 27, but I don't even think we need to deal with that, because if I plugged in negative 27 here, it's going to be a negative answer. So I'm just going to do the positive one. And then I add 4, so x equals 31. Okay, number 6, I've got 4x to the power of 3/2. This is kind of similar to number 2, in that, remember when we divided by 2? I bring this power out front. Then I can get rid of that power. So how would I get rid of this 3/2 on the left and move it to the right? Divided by 3 over 2, what could I multiply by? 2 over 3. So log 1/2, 4x equals -2. Change it to exponential form. I'm going to erase this. So 1/2 to the -2 equals 4x. Okay, what is 1/2 to the -2? So the negative means that it flips, and the 2 squared means that it's 4. So 1/2 to the -2 is what? Just +4. So x equals 1. Number 7, this one is it a log on one side or on both? Both sides. These are the ones that you're going to love. They're so easy. You just set the insides equal to each other. 4x minus 7 equals x plus 5. That only works if they have the same base, but you will really only get examples where they have the same base. Number 8 has a log on both sides. However, I need to condense the right side. So if I condense the right side, what would that look like? ln of what? 3x. Then from there, now I just have one single log on both sides. I can set them equal to each other. So x equals 3. Okay, last two. I want you to try 9 and 10 on your own. And then I will put the answers on the board. So on number 9, there's just a log on one side. So you combine the two or condense by multiplying. And there's no base, so you assume that the base is 10. So I just drew in a little 10 there. And you switch it to exponential form. So 5x squared minus 5x equals 10 squared, which is 100. Then I pulled out a GCF, or greatest common factor, of 5. And factored from there to be x minus 5, x plus 4. But only the 5 works, because when you plug in -4, you get negative logs. So only 5. On number 10, condense. So x squared plus 12x. And then change to exponential form. So 4 cubed is 64. Then I bring that over and factor. And you get -16 and +4. But only the +4 will work.